Alright guys, so in this video we're going to be continuing differentiation by exploring some of the different rules that make differentiation much quicker. So in the last video we learned about the first principle formula known as limit of h tending towards 0 of f of x plus h minus f of x divided by h, and putting any f of x any function into this would give us the differentiated function f of x equals whatever. So some of the things we explored were if f of x was x squared, it would output 2x, and if f of x was x cubed minus 3, that outputted 3x squared. So how do we do it with these two values? How do we suddenly get these values? Well, they both used one important rule, which is known as the power rule. The power rule. Essentially, if we were to write it, if we were to write the function as ax plus b, it would become ax plus b to the ax to the power of n plus b. It would become nax to the power of n minus 1. So what does this mean? So in this case, let's take the x squared value. So in this case, a is 1, x is x, and n is 2, but there's no b. This becomes, so we can multiply the coefficient of x, which is 1 in this case, by 2, because that's the power. See over here, this gets drawn down. And then we subtract the power of x by 1. So 2 minus 1 in this case is just 1, so it's just 2x. Therefore, we get 2x. Let's try it again with x cubed minus 3. So x cubed minus 3. A is 1 again, x is x, n is 3, and b is negative 3. Well, b doesn't make an appearance here. It just becomes, so 3 gets multiplied by here, and then decreases by 1, so that's 3x squared, and then b gets taken away. And essentially, one of the things we also have to realize is the way we write differentials is not using first principles. So the way we write it is, for example, if we wanted to say that we were differentiating x squared, we would say that dy over dx equals 2x. What does that mean? Well, dy over dux is just basically a way of saying differentiating with respect to x. Because in this case, we're using the variable x and differentiating that specific variable. Because let's say we had y cubed minus 3. Let's say that x equals y cubed minus 3. That would become dx over dy. Essentially, using this logic, we're assuming that we have y equals whatever function. That's how we would write it. We would have y at the top and x at the bottom. Or, if we were writing it in function terms, if we were writing f of x equals x squared, then the way we'd write the differential is f, and then we put an apostrophe sign equals 2x. So that's the way we'd write it. That's the different notation for writing the differential. And we see that using the power rule, both of these ones work. So let's just take another example, and you can try it out and pause the video if you like. Let's say we had 3x cubed. Differentiating that, just pause the video if you'd like to attempt it. Okay, so now I'm going to attempt it. So we could say that, well, we could say that it's y equals 3x cubed. So that way, it would mean that way it can be written as dy over dx. And then, as we said, we multiply the 3 by the coefficient. So that becomes 9. Then we decrease the 3 by 1. So it becomes 9x squared, because 3 minus 1 is 2. So that's our answer for that one. Let's do one more problem. All right, let's take this problem. Let's say we have y equals 4x cubed plus 3x squared plus x plus 4. Let's say we have to find dy over dx. So pause the video if you want to find it out by yourself. If not, let's proceed. So let's start with the first term. We have to do each term individually when they're not multiplied by each other, because they're just added. In this case, they're subtracted. If it's just subtracted, then also you do the same thing as we're doing right now. So drag the power down here. So 4 times 3 is 12. Then decrease the power by 1, 12x squared. Then you added 2. So you drag the 2 down, multiply by 3, gives 6. Then the power of x is decreased by 1. So it's just 6x to the power of 1, which is just 6x. Then you have the value of x. So we can say that it's 1x to the power of 1. That's the same thing as x, if we want to make it easier for ourselves. Drag the power down. 1 times 1 is still 1. And then decrease the power by 1. So x to the power of 1 minus 1 is just x to the power of 0. So that's just 1. So 1 times 1 is just 1. So x, we can say it can be differentiated with, let's just erase that and rewrite that again. Differentiated to form 1. And then we have a constant 4 here. When you don't have a value of x attached to a value, so in this case, this is independent of x, then it can't be differentiated. It'll just go away. So this is our differentiated function. We get rid of that value. And let's just do one last problem to ensure that we've actually grasped the power rule. Let's say we have y equals 7x to the power of 4 plus 2 over 3x to the power of 3. Okay, so this one's pretty straightforward. We can just say that dy over dx, which is the way we write it, is equal to, and then 7 times 4 is just 28, decrease the power by 1, 28x to the power of 3. And then for this value here, take it and draw it over here. So that's 2 over 3 times 3 is just 2, so 2x, and then 3 is decreased by 1 because it's the power of x, making it 2x squared. So that's our final value. And remember, if we had f of x equals 2x, let's say, well, we can essentially say that f, the differentiated version of x, which is with this dash, is just 2, because if you think about it, it's 2x to the power of 1, and the 1 gets brought down, multiplied by 2 is just 2, and then the power of x is decreased by 1, which is just x to the power of 0, which is 1. So 2 times 1 is just 2. So that's the answer for that one. So that's the power rule. But before we proceed, let's just first look at some different problems, because turns out that there are other ways if we can write something and it may be more complicated to use a power rule with. It may not be so obvious right now, but trust me, you can always use a power rule, these kind of things. So let's say we have y equals 8 root x plus the cube root of x plus 2 over x. Okay, so this is definitely looking much more unfamiliar, because where are the powers of x? Well, this is using a lot of indices actually, because one recommended thing when doing the power rule is always convert the different x values into their powers. So we can rewrite this as y equals, and then 8 remains, but x can be raised to a power over here. Well, how can we express root x as a power? Well, root x is the same as x to the power of half, which is how we can represent this. And then we have the cube root of x. Well, the cube root of x is just x to the power of a third. And then we have 2 over x. So 2 over x can be represented as 2 times x to the power of negative 1. If you're a bit confused as to how this is happening, just check out my indices playlist where I actually explain how to convert different things. And now they're suitable for power rules. So dy over dx, we could do easily. So we could just bring the power down. So 8 times half is just 4, 4x, and then half minus 1 is negative half. And then this is added to, and then drag this down, 1 over 3x, and then 1 over 3 minus 1 is negative 2 over 3. And then this one, actually, we would not write a plus, because when you bring this down, negative 1 times 2 is negative 2 times x. And then the x is raised to the power of negative 1 times, negative 1 minus 1, which is negative 2. So that's how you could write it. If you want to simplify further and write it without the powers, you could write it as dy over dx equals, and then that would be 4 over root x. That's because x to the power of negative half is 1 over root x, and you multiply by 4, it's 4 over root x. Plus, and then for this one, you would have 1, you would have 1 over 3, and then it would be the cube root of x squared. Yeah, it looks a bit complicated, but that's how you'd write it. And then you'd subtract it from 2 over x squared. So that would be your final differentiated equation. But that's it for the power rule. You could basically use these. You should just convert everything that has an x in it to a power that can be therefore evaluated using the power rule. And that's all you need to know for this rule.